Hello, I'm Steffi de Meijer, a PhD student at KU Leuven, and in this short video abstract I will present our study titled Plasma pTau181 and pTau217 predict asymptomatic amyloid accumulation equally well as amyloid-PET. The amyloid cascade hypothesis states that amyloid plaques are a key driver of pathological processes in Alzheimer's disease, and this has led clinical trials in the last 3 decades to mainly focus on drugs targeting the clearance or production of amyloid. But these clinical trials have not had a high success rate, and this is at least partly due to the suboptimal timing of anti-amyloid interventions in these clinical trials, because they mostly included individuals within prodromal or dementia stages, while it has been suggested that these therapies may be most efficacious when initiated as early as possible. To identify individuals that are destined to accumulate amyloid as early as possible, there is a need for accessible and reliable biomarkers. Therefore, in the current study, we compared the abilities of plasma pTau181 and pTau217 to that of an amyloid-PET scan to predict amyloid accumulation in cognitively unimpaired elderly from the Flemish Prevent Alzheimer's Disease Cohort KU Leuven, or FPEC. Baseline levels of blood-based pTau181 were measured with the ADX-Simoa assay, pTau217 with the Alzheimer-Simoa assay, and we also measured other biomarkers such as GFAP, NFL, and the amyloid ratio with a commercial Simoa assay. All subjects additionally underwent an amyloid-PET scan at the baseline as well as at follow-up on average 5 years later. The amyloid rate of change was calculated by subtracting the baseline centiloid value from the follow-up centiloid value and then dividing this difference by the time interval between 2 scans. Individuals that had an amyloid rate of change higher than the empirically defined cutoff of 2.62 centiloids per year were considered to be amyloid accumulators. This ROC curve shows that plasma pTau181, pTau217 and amyloid-PET demonstrated comparable yet moderate performances to distinguish amyloid accumulators from non-accumulators. And these performances were not significantly different from that of a multimodal biomarker model that included all 3 biomarkers. The other measured biomarkers, so GFAP, NFL, and the amyloid ratio, could not discriminate amyloid accumulators from non-accumulators. This correlation matrix shows that plasma pTau181, pTau217, and amyloid-PET correlate similarly with amyloid rate of change, while the other blood biomarkers, or factors like episodic memory performance, polygenic risk score, age, and education, did not. The strongest correlation in the correlation matrix is the correlation between pTau181 and 217 in plasma, with a Pearson correlation coefficient of 0.93, which suggests that they reflect very similar processes in these early disease stages. When then adding each of the 3 biomarkers of interest, so pTau181, pTau217 or amyloid-PET, to a basic demographic model, which includes age, sex, and apoegenotype as predictors, they similarly increase the predictive value of these models for amyloid rate of change. However, when adding them simultaneously in a multimodal biomarker model, all 3 biomarkers lost their individual predictive values, as you can see by the non-significant p-values for each biomarker. Altogether, these findings indicate that plasma pTau181, plasma pTau217 and amyloid-PET convey overlapping information and therefore predict the dynamic phase of amyloid accumulation with comparable performances. So amyloid-PET might not provide additional value in detecting early amyloid accumulation, but given the moderate performances, future studies should investigate whether other factors can improve performance to enhance clinical and research utility. Thank you for watching and feel free to reach out in case of further questions.